Okay, let's start our talk about ellipses. As you can kind of see off to the left, it's going to be broken into introduction, kind of the anatomy of ellipse. We'll do some examples of graphing and analyzing it, things we can tell about ellipses, and then what to do if you don't have an ellipse given to you in the general form, and then just lots of examples here. So what is an ellipse? Well, an ellipse is a collection of all points, so their distances to two fixed foci, two fixed points, summed to a fixed constant. So in a picture, it's your foci. Obviously, I can't pronounce that. We're going to decide it doesn't matter. So the foci are those middle points, negative C0 and C0, and the distances to any point on that ellipse will add to some fixed number. So that D1 distance and that D1, those two green lines. Here's a nice animation, though, that illustrates that. Okay, so as you see, the distances from the two foci are changing depending on the point as we progress around this ellipse shape. And the thing to look at is, sure, the blue line and the red line totals are given above, but at the bottom you can see that, sure enough, no matter what, those two lengths always sum to that fixed value of 10. So that's what technically an ellipse is. It's a collection of all points of the distances to two fixed points summed to a fixed constant. So anatomy of an ellipse. We'll just start out by writing the general formula here. X minus h and y minus k quantities squared divided by a squared and b squared respectively sums to 1. That's the general formula of an ellipse. And it turns out these values mean something. Back a long time ago, if you took just the top of this expression and got rid of the divided by a squared and b squared, you would have the equation of a circle that's centered at h comma k. So first thing to notice is it's centered at h comma k. And be careful of the signs there. They have to be subtracted, so we may need to rewrite the expression to make sure we get the correct sign on our h and k value for the center. A and b are the horizontal. Well, so take a look at A. A is underneath the x expression. So that A over there on the left, A represents the distance from the center of our ellipse all the way out to that vertex, we're going to call it, on the distance. It's also the same on the right because ellipses are symmetrical here. Oh no, undo, we didn't mean to do that, sorry. Okay, so next, take a look at B. Well, B is underneath the Y, so in the Y, the vertical direction, B is the distance from the center to the vertex in the horizontal, or the vertical direction. And in this case, it's shorter. It doesn't have to be. You could have kind of a more vertical ellipse. So let's see. The book does something where they reverse A and B depending on whether Y comes first and X comes first. And we'll get more into this, but I like to just stick with the same labeling. Yeah, I like to stick with the same labeling. This note down here has to do with if you change the labeling B under your X and Y under your, or A under your Y if you have a longer axis in the Y direction, which is what the textbook does. But in my examples, we're always going to stick with B being the Y direction and A being the distance from the center to the vertex in the X direction. Now, here's a new quantity, and this number C here. C is the distance from the center to the foci, and it's the same on either side. I don't have it in there because I don't want to clutter it up. But yeah, sure enough, C is the same on either side. Should you memorize this? I don't think so. If you label everything like that, you should always be able to draw a right triangle and use the Pythagorean theorem to calculate C or any of the missing values, depending on what you're provided in the problem. So careful here with respect to the Pythagorean theorem. It is a relettering that is different than what we're used to. It's not a squared plus b squared equals c squared. But the way we have our triangle drawn above, it would be side b squared plus side c squared equals hypotenuse a squared. So just be careful that you are applying the Pythagorean theorem correctly for the variables you are using. All right, so next thing we can look at, let's take a look at how to graph an ellipse from an equation. In general, if you're given the equation, well, then you will know you'll have x minus, you'll have x something squared, and you'll have some number. You'll know a, because you'll be given it in the equation. You'll be able to identify it from the equation over y minus some center number squared over b squared. You'll be able to identify a and b from the equation. So you use that information to plot the vertices in either the major or the minor direction. Major being the longer direction, minor being the shorter direction. And then you use the relettered version of the Pythagorean theorem to find this c value, which will allow you to calculate your foci, because you'll know the distance from that center value, which we can also just identify directly from the equation. We'll do lots of examples of this, so if it's a little abstract right now, hopefully that'll assuage those fears. All right, let's stop this one here, and we'll dive right back in on an example shortly.